All right. This is P1. Prerequisite lesson 1. Real numbers. If I go too fast, slow me down. If I'm going too slow, tell me you already know how to do all this and we'll be good. All right. What? Somebody said something. Oh, goodness. Yeah. Tell me, let's see what I want to do. Let me tell you about intervals first. Let me talk to you just a minute about, let's think about a number line. Let's say I have a 5 here. And I wanted to say greater than or equal to 5. What would I need to put on the 5? If I wanted this to indicate greater than or equal to 5. What goes on 5? There's two options. An open circle and a closed circle. Which one would it be? If I want greater than or equal to 5, what goes on to 5? A closed circle, right? That indicates to me that it includes 5. And then it would go off where the numbers get bigger because it's greater than or equal to 5. So this is kind of elementary as far as the greater than and less than sign in the number line. What we're going to do is we're going to pick up with interval notation. Okay, so I need to spend some time telling you what interval notation is because all of our domain and range and things like that is going to be done using interval notation. Now, if I think about this number line and I picture it in my head, the numbers get bigger and bigger this way, right? So I'm going to call this way infinity. And then the direction that they get smaller and smaller and smaller, I'm going to call negative infinity. So now, let me also show you. If I have greater than or equal to, or less than or equal to, I'm going to use a bracket for those to indicate. That's going to be like so that I know that there's a line under it. I know it includes that number. So greater than or equal to, I'm going to have a bracket. Less than or equal to, I'm going to have a bracket. And if there's no line under, and this will make sense when I bring this all together in just a second, then I am going to use a parenthesis. So if you see a bracket, you know it includes the number. If you see a parenthesis, you know it does not. And so what I do with interval notation is I literally tell it an interval that it includes. So if I'm talking about greater than or equal to 5, okay? I'm talking about any number that's 5 or bigger. Okay, so with interval notation, we always start with the smallest and we go up to the biggest. So what's the biggest value that satisfies greater than or equal to 5? Oh, the smallest. Did I say smallest? I told you, y'all are making me nervous because of the way y'all staring. All right, the smallest value that you can be that satisfies greater than or equal to 5, what is it? 5, right? 5 is the smallest it can be. So I start with 5. And do I need a bracket or a parenthesis? Somebody said it. A bracket, because bracket goes with the or equal to, okay? So I'll put a bracket on 5, and then it goes up to what? Infinity. Infinities are always going to get parentheses because you can't actually equal infinity. Okay? Let me show you another. Let's say I told you that x is less than -2. How might I write that in interval notation? What's the smallest value? Always go smallest to biggest. So think about it on a number line. If this is -2, what's the smallest value that x can be? Negative infinity. Do you see that? Because this would actually be open dot going in this direction. So the smallest that it can be is negative infinity. With a parenthesis, because infinities are always going to get parentheses. Up to what? -2. Bracket or parenthesis? Parenthesis. See what we're doing here? It's not a hard concept, it's just a more concise way to write it. How about write that in interval notation? I'll give you just a second to look at it. Got it? What's the smallest x can be? Come on, y'all. It's between -3 and 0. What's the smallest x can be? -3. Bracket or parenthesis? It goes up to what? 0. Bracket or parenthesis? This is saying all the numbers between -3 and 0, including -3, not including 0. One more. Write that in interval notation. Smallest. 5. Ooh, I wrote that wrong. -5. Yeah, sorry. Up to 3. Where's the bracket? Where's the parenthesis? Bracket on 3, parenthesis on -5. Good job. All right, so sometimes we need more than just one interval, okay? Sometimes maybe we need 2 or more intervals. So maybe I have something like this. That I need to say all at one time. Okay? So let's think about what this is saying before we put it in interval notation. This side is saying that x is less than or equal to 2, right? What is this side saying? Then 6, right? But I need them to be all one interval. So yeah, sure. So what I do is I join them together to indicate that together they make one interval. And the way I do that is I join intervals with a U. Okay? So I'll write the first interval, I'll put a U, and then I'll write the second interval. So look at the first one. What's the smallest that x can be? Even smaller. -infinity, because it's going off forever to the left. So I got a parenthesis, because infinities always get parentheses. -infinity up to what? 2, and it stops, right? It stops at 2, and it gets what? A bracket or a parenthesis? Bracket, because it includes it. And because there's another piece, I'm going to skip some area, so I'm going to put a U. And then I want to pick back up where? With a parenthesis at 6. That's exactly right. And then it goes up to what? Positive infinity. That's correct. Does that make sense to everybody? Everybody okay? I don't want to bore you if you understand how to do this. Let me ask you this, and my Algebra 2 kids from last year will remember this. I hope. What if I want to leave only one number out. In other words, I want to say that x can be anything in the whole wide world, but it can't be -3. It can be anything bigger, and it can be anything smaller, but it just can't be -3. How might I write that in interval notation? Does it have two pieces? So let's write each piece and then join them together with a U. What's the smallest value it can be? -infinity. I should probably put 2, leave out a single value. All right, so we said -infinity. And then it goes up to, well, but it stops somewhere. Where's it stop? -3, right? It stops at -3, but then it picks back up at -3, right? It just doesn't include it. So if you do this other parenthesis up to infinity, that back-to-back parentheses lets you leave out just one value. Does that make sense? Because it doesn't actually include it. All right, everybody good on interval notation? Yes, no, maybe so? All right, let's talk about some exponent properties. It should be an easy lesson for you today. That was the only new stuff maybe you hadn't seen. All right, so these come up in Algebra 2 as well. And we talk a lot about them, and you really have to know how to work with them to be able to proceed on in pre-cal. So we'll review them. I know I have my kids do a foldable. I don't know how everybody learned them in here. But there's 7 exponent properties, and individually they're really easy, but when we put them together, it starts stumping people. So I think you'll remember as we look at them, and I'll run through them really quickly. You really don't have to know the names of them, you just have to know what they do. The first one, if we multiply 2 terms with the same base, what do we do with their exponents? You add them. That's exactly right. Y'all remember these? Okay. The key here, they have to have the same base. If you've got different bases in there, you can only combine the ones that have the same base. If y'all need me to expand on any of these, tell me, because I'm just kind of running through them. The second one, if you have a power raised to another power, this one's different than the first one. The first one we add because we're multiplying. This one we're power to a power, so what do we do with those exponents? Multiply them. Those are the two that everybody always gets mixed up on what to do when. If I am dividing with the same base, you subtract. That's exactly right. Y'all remember these. That's really good. What am I missing? What am I missing? How about if the exponent is negative? Change it and do what? Yep. That's exactly right. What if it was negative in the bottom? Like what if I had 1 over x to the -5? You switch it. Every time you move across the fraction bar, the sign on the exponent changes. So this could just go to the top and just become x to the 5th. I told you there's 7, so we got 3 more. Y'all need a second before I move slides? Okay, tell me when you're... All right, number 5. Let's say I'm multiplying inside the parentheses. Now be very careful, because if I was adding or subtracting, this would not work. But if I'm multiplying inside the parentheses, what does that exponent do that's on the outside? It distributes through. I'm going to make a note here just so you remember. Note. X plus y cubed does not equal x cubed plus y cubed. That would actually be a FOIL type problem that you would have to multiply 3 times to itself. Two more. How about if I'm dividing? You give it to the top and bottom. That's exactly right. Is anybody confused or overwhelmed right now? Everybody okay? Do you remember this from Algebra 2? Okay. And then the very last one is the easiest one. Save the best for last. If my pen will work. Anything to the 0 power is what? Always and forever, it's always 1. As long as the base is not 0. So let me give you a couple examples. We'll work through with the properties of exponents, and I'll be about done. So these are in parentheses, but don't let that throw you, because the parentheses are just telling me that what is the operation in the middle here? Multiplication. And what's the operation happening inside the parentheses? Multiplication. And I can do multiplication in any order I want to, right? Because it's commutative. So just put together what you can combine together. Can you multiply 2 times 5? Sure, why not? What happens if you multiply a times a to the second? You get a to the third, right? How did I get 3? There's an implied exponent of 1 there when there's nothing. How about the b's? What would you get? B to the 8th, that's right. You know it's completely simplified when you can't do anything else. Does that make sense to everybody? Let's look at one more. Uno más. There's not a correct order to do these, as long as you do properties each time. You can do whatever property you want first, as long as they're valid properties. So what do you see that maybe I should do first? I would flip the negatives. Make sure whenever you're moving negatives that you're only moving that base that has the negative exponent hooked to it, okay? If there's a coefficient in front, that does not move with it. It's only the base itself. So what happens here is this u comes up and becomes positive. Then I have u2, and this one's going to go down. So in the bottom I have v3, and remember this one's coming down to make v positive 2. Does that make sense to everybody what I did? All right, now what can you do? Adam. What do you have up top? What do you have on the bottom? Good job. Properties of exponents. Everybody okay on that? All right.